Dad, how did this get here? Didn't we just order it like a few hours ago?
When my older daughter asked that, I stopped for a second because it is a simple question with a surprisingly deep answer. Somewhere between a tap on a screen and a box on our doorstep, invisible systems spin up, data races across networks, decisions get made in milliseconds, and the physical world moves. It's fascinating to think what happens when you stream a song, book a hotel room, reserve a flight, or open an app and just expect it to work. All this technology is so fun, and I love working in this industry. I've spent my career building software and systems that make up the internet. I was CTO at Shopify and ServiceNow, an SVP at Slack, an early engineer at Cisco Systems, and now I'm CTO at Webflow. I've helped build data centers, protocols, software, and services, and led global teams along the way. This podcast is for anyone who wants to understand how our modern world actually works, not just shopping and delivery, but the invisible machinery behind nearly everything we do. It is for anyone who's ever wondered, how did this get here? Or how did that actually happen? I'm excited to take you on a journey, to take these layers of technology apart and explain them in a clear, grounded way. You probably think you connect to Wi Fi, you're on the internet, and away you go. Well, I wish it was that simple. I'm Alan Meinwand, and welcome to Pixels to Packages. Hello, everyone, and welcome back to Pixels to Packages. By now, you kind of know how the show works. We take something that feels instant and obvious, and we slow it down until the hidden layers become visible. Back in episode 1, we followed a tap across networks into a data center. In episode 2, we watched HTML, CSS, and JavaScript turn raw data into pixels on a screen. Episode 3, we broke the illusion of there being a single server and traced virtual IPs, load balancers, and distributed systems that make the internet feel simple but are really quite complicated. Now, my daughter keeps telling me and reminding me that this show is called Pixels to Packages, and she wants to know when we're going to get to the physical packages. You know, the good stuff that we all buy using those pixels on the screen that shows up in a few hours. We're going to get there. I promise. But I had a moment recently that made me realize that we need to take yet another detour, another stop first. Because there's a different kind of package being delivered right now across the tech industry. One that runs on the same networks we've been tracing, using the same tech stack, but it changes almost everything. So let me tell you about that very San Francisco and Bay Area tech moment. I was in San Francisco, riding in a Waymo on the way to a meeting. If you haven't seen one, a Waymo is a fully autonomous car, no human driver. The car sees the world through cameras, LiDAR, and radar, and an AI system makes every driving decision, deciding when to brake, when to accelerate, how to avoid road obstacles, when to yield, when to merge, everything. So I'm a passenger in the back seat, being delivered by artificial intelligence through the city streets. Pretty cool. So while the car drove itself, I opened up my laptop and connected the internet using my phone as a 5G hotspot. And then I started working in Cloud Code, an AI-powered code gen tool. I was building a new feature for a product. I was typing prompts. AI is generating code. I was reviewing and refining that prompt in that product in real time. Packets were flying from my laptop to my phone, over 5G, across the internet, into a data center, into an AI model, and back again, all while this AI car navigated San Francisco city traffic on its own. And then that moment really hit me. I realized I was sitting inside an AI system while interacting with another at the exact same time. The car around me was processing sensor data through neural networks to keep me safe on the road, while I was connected to a different AI system over the network, receiving a package of AI-generated code streamed back to my screen token by token. I was moving through San Francisco at 25, 30 miles an hour, being physically delivered by AI, while simultaneously having an AI package, the code, delivered to me over the infrastructure we've been talking about this entire podcast since episode 1. For a moment, I just looked around the car and kind of let that sink in. And I kind of looked at San Francisco. It's a pretty beautiful city. There was no driver. Code was appearing in my screen in what seemed like real time. Packets were moving visibly through the air, through the fiber of the city streets. It felt like one of those moments where you suddenly realize you're watching the future in real time. It was really pretty cool. AI on the outside sensing and steering, AI on the inside coding and creating, and connecting them all with the same stack of protocols, packets, routers, fiber, Wi Fi, 3G signals we've been tracing since the beginning of this podcast. And that's what this episode is all about. We're going to follow a prompt from your screen into what I'm going to call the AI store and trace the responses it streams back and become pixels again. The AI package delivered over network in a loop. And once we have that loop clearly in our heads, we're going to follow it further in the physical world, because this is the episode where pixels begin to move real packages even before anyone presses buy. So hold on, daughter mine. The physical packages are coming, but first we need to understand the AI package that is helping to deliver them. So you open your browser and you type chatgpt.com, or you open the ChatGPT app on your phone, or use Claude or another AI tool. A nice clean interface appears, quiet and minimal, a text box waiting for you. That interface is built on the same stack we've been exploring from the beginning. HTML defines the structure of the page, CSS defines the style and the layout, JavaScript defines how the page behaves. Underneath all that sits the box model, which shapes every element into rectangles that the browser can position and render. You'll remember episode 2 was how those boxes became pixels on your screen. This is that same story again, except the boxes are now waiting for something new. You place your cursor in a text box and you start typing a prompt. The characters actually appear instantly, because at first, everything's happening locally on your phone or your laptop or your device. Your browser updates the internal structure it keeps in memory that represents the page. And when that structure changes, the browser recalculates what should appear on the screen and repaints the pixels accordingly. At this stage, nothing's really left your device. But the moment you push enter, the story shifts from rendering to transport, and everything we traced in episode 1, 2, and 3 comes back into play. Your prompt doesn't just travel across the internet as a sentence. It travels as you probably guessed, packets. Those packets are wrapped in TCP so the message can be delivered reliably and in the correct order, and they're encapsulated in IP so routers can forward them across the internet. And because how all that happens, your device needs to perform a DNS lookup to translate the name chatgpt.com into an IP address, because names are convenient for humans, but of course addresses are what networks understand. From your keyboard, the packets move to your Wi-Fi radio, then to your local router, onto your ISP, from there onto fiber links that run in cables under streets, across cities, and across oceans. You'll recall routers forward them hop by hop across the internet, and the network does not guarantee that every packet takes the same path. It simply forwards them as efficiently as it can, while TCP, the transmission control protocol, keeps track of what was sent, what arrived, and what might need to be resent. IP is doing the routing, TCP is doing the reliability on top of it. And this is exactly what was happening in my Waymo as well. My prompts to Claude Code were taking the same journey, except that instead of Wi-Fi, they're traveling over a 5G cellular connection to a nearby tower, then onto my carrier's network, and from there to the exact same internet backbone and data centers we've been talking about. The protocols don't care if you're sitting at your desk or moving through an intersection at 30 miles an hour. Packets are just packets. And just like we learned in episode 3, the destination is probably not a single server. It's a virtual IP address sitting behind a load balancer at the edge of a data center. Your TCP session reaches that edge, where the load balancer accepts the connection, decrypts the security called the TLS encapsulation that protects your session, inspects the request, opens up a new internal connection to whatever backend service you're going to be connecting to. Maybe it's ChatGPT, maybe it's another code-gen service, some other AI service. One connection runs from your device to the load balancer, another then runs from the load balancer to the systems inside the data center. That should be a pretty familiar pattern by now. The difference is simply what's waiting behind the load balancer this time. Think of the data center handling your prompt, the thing you type into the chat box, as an AI store. In earlier episodes, We visited data centers that returned web pages, product listings, transactions. The shelves of those stores were filled with code and databases. This data center still contains racks, switches, and fiber, but what it holds are different. The shelves of the AI store are stocked with learned patterns, billions of numerical values called weights that were shaped during a long training process and ready to be used the moment you ask a question. Training happened long before you ever typed in your prompt into that chat box. Massive data sets of everything that's possible on the internet were processed through neural networks across clusters of graphics processing units or GPUs, those chips you hear about NVIDIA producing all the time. And the system gradually adjusted its internal parameters through a process known as gradient descent. Over time, the model learned statistical patterns in language, structure, and context across large volumes of text. Now, it didn't memorize answers. Instead, it developed a probability engine, a math score, essentially, that can predict what word or token should come next, given the context of what you typed so far. Those trained weights are what sit on the shelves of the AI store. So that's what training is. Now, inference is something different. Inference is what happens when your prompt arrives to the data center. This is the moment the systems begin generating a response that will eventually take that network, go through that box model, and return all the way to your screen in the form of pixels. So the first step is when the prompt arrives at the data center. And then it goes through something called translation. Your text is broken into tokens. Think of those as little bits. They could be a character, they could be a combination of words, but most often not full words. Those might be pieces of words, punctuation, short sentences, characters. They're just little tokenized bits. Each token is mapped to a number, and those numbers are converted into vectors called embeddings. A lot of new terms, but we're going to get there. Embeddings are the numerical representation of your words that the model can process. So these numbers flow through the layers of the computation inside the neural network, powered by those GPUs. Something called an attention mechanism determines which part of the context influences other parts, while linear transforms, reshape, and combine information as it moves through the network. Under the hood, this work involves massive numbers of matrix multiplications, and that's why GPUs and other accelerators are used. They're designed to perform those operations extremely quickly and in parallel, and you know that because those prompts you type, they get answers really quickly. Now, a lot of that was like a lot of math. But it basically was what you type is tokenized. Tokenized, and those tokens are embedded. Those embeddings are numbers. Those numbers go into a model. The model has a statistical significance and a predictability in terms of what's going to come next. And that's what's delivered back to you. At each step, the system produces this probability distribution of which token should come next, what expects to send back to you next. And once the token is selected, that token becomes the beginning of the answer to your prompt. When you typed in something into ChatGPT, or you typed in something to Claude, and you started to ask it a question, everything I just described happens before you even see the first bit, the first pixel, come back as a response to your question. Now, once the model, the thing running in the data center behind the load balancers that's doing all this magic language embedding and looking at tokens and trying to predict what's next. Once the model begins producing that output, it doesn't wait for the entire answer to complete before sending it back. Instead, the response is streamed as a sequence of small chunks over a connection. Each token or small group of tokens is transmitted as soon as it's generated. These chunks travel from the inference service back through the load balancer out of the data center. Packets move across the internet just as they did on the way in, passing through routers, fiber links, and eventually back to your ISP, or in my case, the 5G cellular network, and arriving at your device. Your browser receives the data and updates the internal representation, something called the document object model or DOM, and the rendering engine recalculates layout and paints the pixels as the response grows. That's how you see things sort of streaming in. The result is that familiar experience of watching your answer appear on the screen in real time as the text expands sort of line by line and answering it as it sort of chunks its way across. And that's exactly what I was watching in the Waymo. So cool. Code appearing at my screen in real time, generated by the AI model in a distant data center, streamed over a cellular network to my laptop, while the car, again using AI, navigated the streets of San Francisco. From my perspective, I typed a prompt and watched the answer appear. From the network's perspective, packets carried that request across the internet. An inference system generated tokens inside of a cluster of GPUs behind a load balancer, and those tokens streamed back using the same infrastructure until they became pixels on my screen. Transport led to computation, and computation, again, returned back to transport. So fun. Okay, up to this point, everything we've followed ends as pixels on a screen. An answer appears, perhaps a paragraph or text or generate a block of code in my case. It feels abstract because nothing physical has happened yet. We haven't moved any atoms really yet, except for the atoms of me in the car, I guess. But this is the point where the story takes a bit of a turn. Those pixels increasingly led directly to decisions that reshape the physical world. See, retailers today, running commerce, run predictive models that analyze browsing behavior, historical purchases, seasonal trends, regional patterns, and even weather forecasts. Those models generate predictions about where demand will appear in the next week or the next month. Based on those predictions, inventory, physical stuff, starts to move before even a customer places an order. Products are positioned across warehouses and fulfillment centers, so when a customer eventually presses buy, the items are nearby. That's part of how they get there so quickly. The customer experiences incredibly fast delivery, but what actually happened is that the software anticipated the demand earlier and quietly rearranged the physical supply chain in advance. Pixels generated by browsing behavior became data. That data informed models. Those models running inference predicted demand, and that in turn moved inventory. So when the order arrived, when my daughter or I actually hit that buy button, the package was already close to us. Or when you hit a buy button, the package thing you're looking for, come in that cardboard box, is probably already nearby. This is a loop where digital signals begin to move physical goods. This is where it gets really, really interesting. Right now, the AI store mostly answers questions. You read a response and decide what to do next. But the next step is the systems that act directly on your behalf. Instead of simply recommending that inventory be repositioned, the system might execute the move. Instead of suggesting a shipping route, it might book the shipment. Instead of flagging how stock is getting low in a certain location, it might place the order automatically. All of that relies on the same infrastructure we've already been following. The same packets will move across the same networks, through the same data centers, and the same distributed systems. The difference is the AI store would not just respond to the request, it would take actions across other systems connected through the internet. This is what people increasingly mean when they talk about agentic commerce. The ability to actually move things based upon what agents are doing without humans in the loop. It's a really, really cool thing. And it's all based upon the technology that we've been talking about already. So I started this episode on Waymo, being carried by one kind of AI while receiving another kind of AI, cogen, over the network. The truth is, we're already living inside these systems. They drive us. They write code with us. They quietly reposition the products while we buy, even before we know we want to buy them. And it all rides the same infrastructure we've been tracing since the beginning. Episode 1, we talked about packets and DNS and moving across networks. Episode 2, we talked about code turning into pixels through the box model. Episode 3, we talked about distributed systems that sit behind that simple tap in the data centers. And in this episode, we followed the prompt while in AI to the AI store and traced how AI generated packages and physical products are become part of the exact same loop. And yes, I know, we still have not shipped anything to my doorstep yet. That is coming, I swear it is. And I keep telling my daughter we're getting closer. I'm Al Monwand, and thank you for joining me for this episode 4 of Pixels to Packages.